2018 Paper 1, Question 12. Polynomial. Given a function, AB constant, it's given that x minus 3 is a factor of the function. That means when we put equals 0, x minus 3 equals 0, x equals 3, when we substitute x equals 3 into the function, no remainder according to the factor theorem. So for part A, we put x equals 3 into the function, 4 times 3, 3 plus 1 square, plus a times 3 plus b equal to 0. So for unknown, 3a plus b is equal to, for this one, it is a number. You can use calculator. It is 192, so put it to right hand side become negative. For this equation, 2 unknown, so we can't solve it. So we need to continue to see. When fx is divided by x plus 2, the remainder is this one, 2b plus 165. So for this, we'll use the remainder theorem. Put x plus 2 equals 0, that means x equal to negative 2, and then substitute to the function again. Then the remainder is 2b plus 165. So let's substitute. 4 times negative 2 plus 1 square, plus a times negative 2 plus b equal to 2b plus 165. So unknown first, it is negative 2a plus b. And then this one move to another side, that means left hand side become minus 2b. And for number, this one and this one. So we can put it to right hand side and then use 165 minus this part. Then we can get 173. Then we can simplify, so it becomes negative 2a minus b equal to 173. For this same one equation, 2 unknown. But if we combine with this one, simultaneous equation, 2 equation, 2 unknown, a, b. Then you can use calculator, program 2. So you press 3, 1, negative 1, 92, negative 2, negative b, 173. Then you can get a is negative 19, and then b is equal to negative 135. Okay, let's see part B. For part B, someone claims that the equation fx equal to 0 has at least one irrational root. At least one, that means it is more or equal than 1. Irrational, actually, that means it can't change to the fraction p over q. And remember, p, q are integer. That means it can't change to a fraction. The fraction, the numerator and denominator are not integer. Okay, so no fraction. So let's see some example. For irrational, for example, pi is irrational. Sine 7 degree, irrational. Okay. Or for example, root 2 is also irrational. So let's see B. For finding the roots, actually we are doing the factorization, and then we'll use the division to find the factor. So let's expand it first. So for x, and then for x plus 1 square, that means x plus 1 times x plus 1. So it is x squared plus 2x plus 1 plus minus a 19x minus 135 equals 0. So we do the expansion, 4x cubed, and then 8x squared, and then 4x, and with this one, so it's negative 15x minus 135 equals 0. So this is polynomial. Then we can use the short division. Just coefficient 4x negative 15 negative 135. Then because we are using the factor x minus 3, so that means it is 3. First, just copy 4. So 4 then times 3, 12, put it here. Plus, remember, for short division, 8 plus 12, 20, 20, and then times 3, 60. Then plus, add them, 45, and then finally 45 times 3, positive 135, and then add them, 0. So the factor x minus 3 and then time, because originally is power 3, so decrease 1 freedom, 1 degree, so become x squared. So 4x squared plus 20x and then plus 45 equal to 0. So that means x is equal to, for this one is 3, and for this one equals 0. So for this part, actually it is rational. So that means not irrational roots. So for this one actually you can first you can use calculator. That means the formula 1 to solve this quadratic. So 4, 20, 45, formula 1, then actually you can get math error. That means no real root. But you need to show to the examiner, so you can use delta to check it. So for delta, it is b squared. That means 20 squared minus 4ac, 4 times 45. So it is negative 320. So you see, it is a negative number. So no real root. So you can see one with not irrational roots, one no real root. So that means it is not at least one irrational. No irrational root. So we can conclude the claim is wrong.